Someone respond, yes, you can hear me on the chat. Okay, excellent. All right. Okay, so the first question. So welcome to Calculus After Hours. We're going to take the first question here from Tom. He wanted to do 3.5, number 29. Okay. All right, so 3.9, number 29, 3.5, number 29. It's a question of matching heights. Okay, so give me a second. Okay, so we have two functions here. The first one, we have f of t equals to negative 16t squared plus 32t plus 48. All right, so it says, so let me just read this real quick. A stone is thrown from the edge of a bridge that is 48 feet above the ground with an initial velocity of 32 feet per second. So that's our initial velocity here and the initial height. So now a second stone is thrown, but this one is thrown from the ground. All right, so from the ground, this is this equation here plus v0t. All right, so we have both of these equations here, and we want both of the stones to reach the same height. So in order to first, we'll start with this f of t, and I want to determine what the maximum height is for that function, f of t. So I can do that by taking the derivative. All right, I can take the derivative here, and I'll have negative 32t plus 32. So that defines the velocity function. All right, so what I'll do is, all right, I have the velocity function, and I'll set it equal to 0. All right, so that tells me when the velocity is 0, that is, it has reached its maximum height. All right, so solving for t, we can see that t is equal to 1. Okay, so knowing that at that time I have the maximum height, in order to find what the actual maximum height is, I'll plug that in to my original function, which is the displacement function. So doing that, times 1 plus 48. So here, this is 16, negative 16, plus a positive 32 is 16 plus 48 for a total of 64 feet in this case. Okay, so that is the maximum height reached by that first stone. So now let's go to our second function. All right, if you're having trouble following, just let me know on the chat. Just send me a question and I can backtrack or slow down or anything like that. Okay, all right, so given this, I'll look at g of t. Now, and then I'll actually find the derivative of this. Okay, so doing that, keep in mind v0 is fixed, so I can just treat it as a constant. So I'll get negative 32t plus v0. All right, so now having that here, negative 32t plus v0, I want to find out when does it equal to 0? So when is all right, and I'll solve for the time. Again, in terms of v0, v0 is still going to be part of my equation for now. I have to find v0, and I'll find it in the next step here. So solving for t, I'll get 32 over, sorry, that should not be it, v0 over 32. Okay? All right, so now we have the time at when it reaches the max height, and now I'll go back to my displacement here. So let me scroll this up a little bit. so now I'll go to this function, g, and I'll plug in v0 over 32. Squared. Okay, so I'm going to switch over here. Okay, so now we have. Okay, so now we have this. Let's see here. All right, so now we have this function here, and I want to find out when is that equal to when is that equal to 64. All right, so okay, so now we go ahead and we solve for v0. Here we notice that we'll get $64. All right. Okay, and then from here, this looks okay. So I think here we'll multiply this by 32 over 32 to get a common denominator. And we'll get negative 16, 32 squared, v0 squared plus 32 v0 squared over 32 equals to 64. All right, so adding these up, this is going to give me 16 over 32 squared times v0 squared equals to 64. Okay, now notice I haven't multiplied any of these out. I'm assuming that, well, we don't have a calculator, so I'm just doing all the work based on not having a calculator here. And we'll see that solving for v0, and then taking the square root, and I only need the positive one. We'll get v0, that'll be 8, that'll be 32, and that'll be 4. So v0 divided by 2, 8 divided by 4 is 2, times 32 should be 64. What are the units? Feet per second. All right, feet per second. There you go. All right, so that would be my initial velocity for the stone thrown from the ground so that it reaches the exact same height as the previous stone, which was thrown with an initial velocity of 32 feet per second. Okay, what do you guys think? Any questions on this example here? No, we're okay. Tom, does that answer your question? Any question on the steps that I took? All right. If there's no question on this one, I can move on to any other question you might have, or anyone might have. Come on, guys, don't be shy. Okay. All right. So here we go. So the next one. Next, we had a question from Ismael. We're gonna look at question on 3.1, number 31. Okay. So let me look. Turn to this page here and. Okay, so we're asked for the following functions and points. Find f prime at A. Determine an equation of the line tangent to the graph of f at A f of A for the given value of A. Okay, so here, 31, we have f of x is 1 over the square root of x. Okay, and then we're asked, we're going to find the equation of the tangent line at when A is equal to 1/4. Okay, so in 3.1, I believe, yes, we are going to use the limit definition. And here, feel free to use, you can either use this definition. Okay, you're free to use this one. Or we can use the limit as h goes to 0 of h. All right, so just keep in mind these two expressions are equivalent, so we can use either one of these. All right. So here I'm going to look at the first one here. All right, so if I do that, the first thing I want to do is I want to eliminate this complex fraction, right? Whenever you have any problem that looks like this with a complex fraction, the first thing we want to do is we want to see, can I get rid of, or let me get rid of this complex fraction. All right, so the first thing I'll do is I'll multiply by x all right, so I'll multiply by the common denominator, which is going to be the square root of x times the square root of a. Now doing that, we get square root of a minus square root of x over, and this is limit as x goes to a, of x minus a times square root of x times square root of a. All right. Okay, now here is we can multiply by the conjugate at this point, or what actually I like doing here is I'm going to take this here. So I still have a problem letting x equal to a down here. So I'm going to see if I can eliminate that problem. Now one thing I'm going to do is I'm going to rewrite it. All right, so I'm going to rewrite this. So I'm just going to factor out a negative. And not only that, I'm going to use the factoring technique here where I'm going to treat this as a difference of squares, right? But in this case, I'm going to have square root of x minus square root of a, square root of x plus square root of a, right? And I'll leave that as is there. Okay, now doing this, we notice now I can reduce that factor right there. So the next step would be, let me reduce that. And now doing that, the resulting expression is very nice here. Okay? Now, given this expression, I have no problem letting x go to a. All right, so here, doing that, let x approach a. All right. And doing that, we'll get -1. We'll get of a. And now, simplifying a little more, we'll get 2 square root of a times a. All right, so now this gives me the expression for the derivative. And now the next thing is you plug in 1/4. So I guess here, all right. -4. All right, and that gives me the slope of the tangent line. To find the equation, right, what you'll do is you'll take the 1/4 and you'll find f of 1/4 to find the y value for the equation. All right, and then you can use that to find the equation, right? Well, we'll know all those values, right? F prime of a, we just found. A is 1/4 or 1/4, and then f of a you can plug into your original function to determine what that is. All right, I'll leave that problem as is. I think the rest of it you guys should be able to do on your own. All right, Ismael, does that answer your question? Is there any step you'd like me to go over again? Okay, excellent. What can I do next? Or if anyone else has a question on this problem. No, we're all good. Anything else, guys? All right, 3.6, number 19. All right, so it's a 0-0 right now, Noel. It is very entertaining. Okay, so let's see. 3.6, number 19. Okay, good. So here's a chain rule. All right, so we're yeah, it sure is. Okay, so 3.6, number 19. All right, so this is a chain rule. So we have y equals to 3x squared Yes, please mute your microphones. I think if you don't want anyone else to hear you coughing or doing anything else, please. All right, so for this one, okay, so we start off, we want to find the derivative. Again, right, think of this as layers, right? The outer layer is this function that's to the 10th power, all right? And the inner layer is this function here, this quadratic, 3x squared plus 7x. So, okay, we start, you want to find the derivative. So start with the outer layer, right? The outer layer is telling me use the power rule here. Leave the inside alone, right? We're not doing anything to that function. And now that'll be a 9. Okay, and then times here, the inner one would be 6x plus 7. All right, and that's the derivative of the inner function would be 6x plus 7. Okay. All right. And that's it, right? Again, the inner layer is just this function, right? There's no other, nothing else that needs to be done here. Okay, Tom, does that answer your question on number 19? I'll do number 14 next. Okay, so 3.6, number 14. All right, yeah, that's a good one. Okay. All right, so 3.6, number 14, we have y equals to sine square root of x. All right, so again, the chain rule, we start with the outer function, that is the sine. So when I take the derivative, this will be cosine. Again, leave the inside alone. Square root of x. Now I peeled out that layer, right? I'm done with this. Now I make my way to the inside, which is square root of x, which we've shown in class previously that that is the derivative for the square root of x. Or you can just apply the power rule, right? 1/2, bring it out in front, drop the power by 1, and we get x to the negative 1/2, which is down here. So just rewriting this, this should look like that. All right. All right. All right, that's a good question. Any questions on this one, or if not, throw out another question there that we can go over. 52 from page 163. Okay. Okay, so hold on, let me write these down here. So we're going to start off with harmony 52, still from 3.6. All right. And then 3.5, number 39. Okay, I'll get to that one after. 3.5, number 39. Okay, so let's start with 3.6, number 52. I'm going to have this strange looking function. All right, so let's see here. Okay, so wow, there's a few layers here. I'm actually, let me get a better idea of. All right, so I'm gonna write it like this. Sorry about the pen marks there. All right, and now I'm gonna start with this outer layer here. So I'm gonna start here using the power rule. 1/2. Leave the inside alone. And drop this down by 1. So that gives me a negative 1/2. Okay, now I'm going to work my way in here. So times here, I'm going to open a bracket here, but it's just a grouping symbol. So doing that, we'll start off with the derivative here. So this will be 1. All right. Plus, here, this is a chain rule kind of nested inside here. So that'll be 1/2 the derivative of that using the power rule. 1/2, but again, the chain rule for this function. So times 1 plus 1/2 x to the negative 1/2. All right, now look at this is the only thing that gets multiplied by that, right? Because the chain rule applies here, and we're using the sum rule on this function out here. Okay. All right, that was an interesting one. Any questions on this one? All right, kind of go through it, read through what I wrote. It's a little involved. It's a little tricky. That kind of threw me off here, those nested square roots. All right, that's a good problem. Okay, what do you guys think? We're comfortable with that solution? Okay, so no one, if no one has a question on this one, I'm going to move on to Wellington's question in 3.5, number 39. Okay, so the position in meters of a marble rolling up a long incline. So this is 3.5, number 39. So here I don't think you need the chain rule for number 39. You can use just the product rule, right? There's no nested function in here. So if this is my position, right, you can think of this as, right, or I guess you could think of that as a chain rule, but the derivative of the inside is just 1. Like, it is the chain rule, you're right, but the derivative is just going to be 1 on the inside. So I'll omit the graphs. The graphs you can do using some kind of graphing uh, device, Desmos or anything like that. But the velocity function, all right? So we can do that by finding S prime. So again, we'll use the product rule here, so we can take the derivative of this. We get 100. Leave the other one alone. Now we work on this one, right? -1 times 1, the derivative of the inside here. Okay? All right. Okay, so now this will be all right, so it'll look like this. All right, and then if we want to combine this, we can multiply this by t plus 1. All right, and that would be my velocity function. Okay, so the next thing it says to graph the velocity of the function and give a description of the motion of the marble. All right. Oops, excuse me. All right, so let me look at what the graph of this looks like. So here, let me graph this. Excuse me. All right, so the graph of this, it'll look something like that. Right, this is the velocity function. All right, so it looks here rolling up a long incline. All right, so we could see here that the velocity starts out really high in this case, and then it starts just kind of to slow down as the time moves forward, right? If this is t, and that's s prime, the velocity. As time increases, the velocity is decreasing as it's moving up the incline. Now here, at what time is the marble 80 meters from the starting point? All right, for D and E, so for D, right, what we want to do is we want to solve, so at what time is the marble 80 meters from its starting point? We want to solve for T here. Okay, so you'll get something like 80t plus 80 is equal to 100t. Bring the 80 over, right, or when t is 4 seconds. All right, so at 4 seconds, it is 80 meters from its starting point. And for E, at what time is the velocity 50 meters per second? So that would be our velocity here. So 50, when is that equal to All right, and actually solving here, we'll get I can 50 t plus 1 squared 2, and then we take the square root, and we'll get this. Here, I have to make sure I don't need both of those. We have, all right. In fact, we're just going to need, which is approximately 4 seconds. All right, so after that many seconds, 4/10 of a second, the velocity would reach 50 meters per second. Okay. All right, that covers that one. Any questions on this one? The quiz will cover anything that is on derivatives. So whatever up to what we did on Tuesday, implicit differentiation. So anything that, it won't be anything too involved for implicit differentiation, but anything that will involve the chain rule, the product rule, the sum rule, anything like that, just solving derivatives. Okay, so that covers this one. Any questions on this one on 3.5, number 39? We're okay with that one? Okay, so now the next one here, Ismael asked 3.7, number 13. All right. Okay, so let me change. So 3.7, number 13. Okay, so here we go. So we're asked to, we have sine of x times y equals to x plus y. And we're asked to use implicit differentiation to find dy dx, or find y prime. All right, so let's start with the left side here. All right, so here, again, chain rule here. So this will be cosine. Leave the inside alone. Now, moving my way in here, that's a product rule, right? So something like this, right? The derivative of this one here, x is 1, leave the y alone, plus leave the x alone, derivative of y. Again, y is a function of x, so it'll be y prime. All right, and then moving on here, we get 1 for the derivative of x, and then y is y prime. Okay, and now I have to solve for y prime. So what I'll do here is distribute out here. So I'll get y cosine of xy plus x y prime cosine of xy equals to 1 plus y prime. Okay, so anything that has a y prime, I'm going to bring to one side. So I'll bring this over here, and I'll bring this one over here to this side. So we'll get x all right, and then almost done here. We'll factor out the y prime. and we'll get this. All right, and then that solves our problem here. So that is dy dx, or the derivative y prime. All right, Ismael, does that any questions on this one? Or anyone else, any questions on this problem? All right. All right, 3.7. All right, let's do another one of these implicit differentiation. Number 17. All right, all right, these are all pretty good. All right, let's do that one, number 17, the implicit differentiation. Okay, so here, number 17, we have a cosine of y squared plus x equals to y squared. Excuse me. All right, so again, we start here, do the chain rule. So that'll be negative sine of y squared and multiply the derivative of the inside here, which is going to be 2y y prime. Derivative of x is 1, and then here 2y y prime. All right, now we have to solve for y prime. So I'll bring everything that has a y prime over here. So I'll rewrite this like this. And actually, let me rewrite it without all these negative signs. I can divide by a negative. And actually can factor out. Just leave it like that. All right, and then dividing by this here, we'll get y prime equals to 1. All right. So who asked this? Unknown sender. Does that help you out? And Tom, that was another example of implicit differentiation. And yes, the Giants one. Okay, great. Anything else? Can we can do another one. 3.7, number 29. All right. Okay. So next thing, we're going to stay on 3.7 and we're going to do number 29. Okay, 3.7, number 29. So we have cosine of x minus y plus sine of y equals to square root of 2. Okay, so in this question, we're asked to verify that the given point lies on the curve. Okay, so given point is pi over 2, pi over 4. All right, so we can verify this by just plugging in here. Sine of pi over 4 equals to root 2. Okay, and then here, solving or simplifying here. All right, so that verifies that they are in fact on the same or on that given curve. So the next step is to find the equation of the tangent line to that curve. All right, so I'll start by finding y prime. So here we have sine x minus y. Derivative of the inside is going to be 1 minus y prime plus, sorry, should be a negative, plus cosine of y times y prime equals to 0. All right, so now my next step here is I have to solve for y prime. So distributing here. Okay, and bringing this over, sine of xy, and then I'll factor out a y prime. All right, so now we get an expression for y prime. All right, and now this expression, the next thing is I'll plug in the points that I have here to find the slope of the tangent line. So that gives me sine of pi 2 minus pi over 4. Okay, and then simplifying here, we'll get sine. This will be pi over 4. Right, and all of these are root 2 over 2. And we should get 1/2. 2, 2, okay. All right, so that's the slope of the tangent line, and then now we just, given those points, our equation would look something like this. And that would be the equation of the tangent line. I'll leave it as is. You can simplify it, and I'm sure you guys can take it from there. Okay, how you guys doing? Any questions on this example here? Any of the algebra or just moving over of things and anything like that? Okay. Uh, I can take one more if you guys have one. If not, we can call it a day there. Okay. So, okay, yes. If there's no questions here, then I think we can call it a day. Thank you guys for joining me. I'll update that. I'll send you guys a link later, and I'll tell you where you can find this later. And so yeah, I'll just send you a link later, and I can show you where you can find it. All right, I gotta sort that out. All right, yeah. De nada. I hope you guys found this useful, and if you did, then we can do this again. Yes, Samurai Gunman. There is a quiz tomorrow. Correct. All right. Okay. You guys have a good night.